Welcome to Easy to Learn Technical Skills. Today I would like to explain about the concept of AVL tree. So AVL tree is a tree in which invented by Adolphus M. Landis in 1962. So this AVL tree is a self-balanced binary search tree. AVL tree can be defined as height-balanced binary search tree in which each node is associated with the balance factor, which is calculated by subtracting the height of the left subtree minus height of the right subtree. So we can have the formula height of the left subtree minus height of the right subtree. So this is a formula for calculating the balance factor. So while we calculating the balance factor, if the balance factor of any node is 1, it means that left side subtree is one level higher than the right hand side subtree. So if the balance factor of any node is 0, it means that the left hand side subtree and the right hand side subtree both are equal size. So if the balance factor of any node is -1, it means that the left hand side subtree is one level lower than the right hand side subtree. So this is the way we have to calculate the balance factor. So the balance factor is equal to height of the left subtree minus height of the right subtree. So every time while we having the node, you have to calculate the balance factor. If the height of the left subtree and height of the right subtree is equal, there is no need to do the rotations. So already we know how to calculate the height of the given. So the height will be calculated from the bottom to top. So in the binary search tree, we already know the concept of binary search tree. So the tree which having the root node, the left hand side value should be lesser than the root node and the right hand side value should be greater than the root. So now I'd like to explain how to calculate the height of the event. So according to this diagram, in the 65 there is no left hand side and there is no right hand side. So 0 minus 0. So the total value is called as 0. And 85 there is no left, there is no right. So simply 0 minus 0 is equal to 0. And 125 is a leaf node. So the 125 does not contain any left hand side children and the right hand side children. So the answer is 0. And 175 there is no left and there is no right. So equal to 0. And 25 there is no left and there is no right is equal to 0. And in 75 we have only one branch is there in the left hand side. So the 1. And the right hand side we have only one branch. So minus 1 is equal to 0. So the given balance factor is here 0. And in 50, so in the left hand side we have only one branch and the right hand side we have to visit the depthmost node. So whichever the branch having the highest level, you have to visit that. So according to the situation, there is a two levels are there. So we can able to calculate this. So 1 minus 2 is equal to minus 1. So according to the statement, if the balance factor of any node is -1, which means that the left hand side subtree is one level lower than the right hand side subtree. So according to this diagram, so this level is one level lower than this level. So this is the way, that is what we are going to get the -1 here. And now we are going to calculate the height of the. So in the left hand side we have the depthmost node is called as first one, this one, second this one, and third one you can take this one. So 3 minus, and the right hand side we have the depthmost node is either you can take this 2. So 2. So the balance factor is 1. So according to the previous statement, if the left hand side branch is one level higher than the right hand side branch, we will get the answer as 1. So if the balance factor is getting 0 or 1 or -1, the tree get will be balanced one, or else we have to do the rotation. So the rotation will be takes place based on some formulas. So there is majorly two types are there. The first one, single rotation, and the next one, double rotation. In single rotation there is a left rotation and there is a right side rotation, and the double rotation, left right is there and right left is there. So these are the four rotations are there. So according to this four rotation, we are going to do the rotation of the given tree. So while we doing the insertion operation, if while every time we have to check with the balance factor, if the balance factor should be satisfied the 0, -1 and 1. If the balance factor exceed than this limit, we have to do the rotation. So how to do the single left rotation? So first we have to take the insertion of 1, 2, 3. So first time we are going to insert number 1. So what will happen? Now we have to check the balance factor of 1. So what is the balance factor of 1? So there is no left hand side and there is no right hand side. So 0 minus 0 is equal to 0. According to the first state, the conditions become true. And now we are going to insert number 2. So while you doing the insertion, first we have to check with the root node. If the incoming value is higher than the root node, going to the right hand side and place the value as number 2. And now we have to check the balance factor of 2. So here 2, 0 minus 0. Why? Because there is no left hand side and there is no right hand side. And the 1, there is no left hand side, so 0 minus, and right hand side we have only one node is there, so 1. So the situation is minus 1. So which means that if the right hand side branch is one level higher than the left hand side, you may get the answer as minus 1. So according to the situation, there is no rotation will be takes place because the trees get balanced one. And now we are going to do the insertion of number 3. Now the 3 will be inserted. So first you have to compare with the root value. So the root value is lesser than the insertion value number 3. So come to the right hand side, and in the right hand side we have another node is called as 2. So we have to compare with the next level is called as a 2. So 2 less than 3. So conditions become, so which means that 3 is greater than the root value called as 2. So have to come to the right hand side, and now we have to check the balance factor. So according to the situation, the balance factor is, so in 3, 0 minus 0. Why? Because there is no left hand side and there is no right hand side. So for number 2, there is no left hand side. So 0 minus, right hand side we have only one level is there. So 1. So 0 minus 1 minus 1. So the balance factor is satisfied. And number 1, so there is no left hand side branch. So 0 minus, and the right hand side we have two levels are there. The 2 level you have to make it as 2. So the answer is minus 2. So the conditions become false. So you have to do the rotation. When the tree is increasing in the right hand side order, you have to do the left hand side rotation. So while you forming the big tree, so you have to remember this, when the tree will be looking like this in this fashion, you have to do the left hand side rotation. According to the situation, the tree will be increasing in the right hand side fashion. So if the tree is increasing in the right hand side fashion, you have to do the left hand side rotation. So first you have to take that where the problem is arised. The problem is arised in the top level nodes. So now you have to do the rotation of topmost nodes. So now you have to take that this node should be in the left hand side order. So you have to do the left rotation. So already I said, whenever the tree is increasing in this fashion, you have to do the left hand side rotation. And now this 1 will be coming to the left hand side of the 2. So after the rotation, the 1 will be coming to the left hand side of the given tree, and 3 as usual it will be there in the right hand side of the 2. And this is the way the tree is rotated. Now we have to check the balance factor. So 3, there is no left, there is no right, is equal to 0. And 1, there is no left and there is no right, is equal to 0. And 2, only one level is in the left hand side and only one level in the right hand side. So 1 minus 1 equal to 0. So this is the way we have to check the balance factor. If the tree is imbalanced, you have to do the rotation. So while you doing the rotation, first you have to take that whether the left hand side rotation or the right hand side rotation will be takes place. So already I said, when the tree is increasing in this right hand side fashion, you have to do the left hand side rotation. And now I am going to explain right side rotation. Insert 3, 2, 1. So first you have to write the incoming node is called as a 3. So first node is called as the root node. Already we knows that. So 0. So 0 minus 0 is equal to 0 because there is no left hand side and there is no right hand side. And the next node is called as a 2. While we inserting number 2, compare with the root node. The root node is greater than the number 2. So come to the left hand side. So come to the left hand side and place the value. So 2 will be inserted in the left hand side of root node is called 3. Now we have to calculate the balance factor. So into, so 0 minus 0 because there is no left and there is no right. And the conditions are satisfied. And number 3, the left hand side we have only one branch here. So 1 minus, the right hand side we don't have anything. So simply 0. So 1 minus 0 is equal to 1. The conditions are satisfied. And now we are going to insert number 1. And now we have to calculate the balance factor. So according to the 1, there is no left and there is no right, is equal to 0. And 2, on the left hand side only one link is there and the right hand side there is no link. So 1 minus 0 equal to 1. So according to this 3, the left hand side we have 2 levels are there. So here the answer is 2 minus, and the right hand side we don't have anything, so 0. So 2 minus 0 is equal to 2. The imbalanced factor is occurred. So now you have to check the condition. So where the rotation will be takes place, you have to find the rotation first. So now I am going to give some tips. So when the tree is increasing in the left hand side fashion, do the right hand side. So while you constructing the bigger size tree, just look at this direction. When the tree is increasing in this fashion, do this rotation. So now the higher level position only the problem arises. So now you have to do the rotation of the higher level nodes. And now you have to make a 3 is the right hand side of 2. So initially 3 left hand side 2 will be present. Now you have to make it as 2 right hand side. You have to make the 3 and 2 left hand side as usual 1, and this is the way the tree will be constructed. Now we have to check the balance factor of 3. So 0 minus 0 is equal to 0. 0 minus 0 equal to 0 for 1. 1 minus 1 is equal to 0. So the trees get balanced 1. So this is the way. So single right rotation will be takes place. So what is called as left right rotation. So I'm going to insert some values. According to that I will explain this concept. So insert 3 comma 1 comma 2. So the first value called as 3. So first you have to form the tree. So the first incoming node is called as a root node. So for this tree there is no left, there is no right. So simply 0 minus 0 is equal to 0. The tree is balanced as of now. And now we are going to insert number 1. So in this root node you have to compare with the 1. So 1 is lesser than the 3. So come to the left hand side, form one child, and you have to make the connection and place the value as 1. And now have to check the balance factor. In according to the 1 there is no left, there is no right, so answer is 0. And number 3 root node, there is a left hand side only one level is there and the right hand side there is a 0 level, so 1 minus 0 equal to 1. The tree get balanced as of now. And now we are going to insert number 2. So 3 and 1 will be there, and now we are going to insert number 2. So while we comparing with the 3, 2 is lesser, so come to the left hand side. And while we comparing with 1, 2 is greater, so go to the right hand side of 1 and form one node and place the value as 2. So now I have to calculate the balance factor of 2. So 2, 0 minus 0 equal to 0. Why? Because there is no left, there is no right. And 1, there is no left and there is only one right is there, so answer is minus 1. So the conditions are satisfied. The tree is balanced as of now. And now comparing the 3. So in the left hand side we have 2 links are there at the depth. So 2 minus, and the right hand side we don't have anything. So 2 minus 0 equal to 2. The tree got imbalanced 1. So now we have to do the rotation. So which rotation we need to take place at first? So I will give one tips. So when the tree is increasing in the left as well as the right fashion, just remember this. When the tree is increasing in the left as well as the right fashion, first you have to do the left hand side rotation and then you have to do the right hand side rotation. So just remember this. When the tree is increasing in this fashion, that means left right fashion, first you have to do the bottom level rotation. So in the bottom level rotation, first you have to focus on the left, and the top level rotation you have to focus on the right. So this is the way we have to do the left right rotation. So in this example the tree will be rotated as, first you have to rotate the left hand side. So here 1 coming to the down and 2 will go to the next level. So the tree will be rotated in the anti-clockwise. So first you have to do the left hand side rotation. So this will be coming to the down and this will be going to the previous position. So now we have to do the rotation. After the single rotation, as of now the tree will be looking like this. So whenever we are going to do the rotation, first you have to take the in-order traversal of the given tree. If the in-order traversal is equal to, after the rotation of the in-order traversal, then your answer is correct. So first you have to take the in-order traversal. According to the in-order traversal, first you have to visit the leftmost node. There is no left value, so there is nothing is there. Then we have visit the root node, then visit the right hand side node. Once the left hand side is over, go to the root node. So 1 2 3 is your answer. So after the rotation, a single rotation, you have to take the in-order traversal of this one. So first you have to take the in-order traversal. The leftmost node is called as 1. Then visit the root node is called as a 2. And there is no right hand side, then go to the root node is called as a 3. So answer is 1 2 3. As of now your rotation is correct. And now you have to check the balance factor of 1. So 0 minus 0 equal to 0 because there is no left and there is no right. And compared to 2, there is no right hand side and only one left is there. So answer is 1. And while we comparing 3, so in the left hand side we have 2 levels are there. So 2 minus, and the right hand side nothing is there, so 0. So 2 minus 0 equal to 2. Conditions are false. So now how to do the top level rotation. So now this will be the next level rotation. According to the situation, we already knows that if it is a single side fashion, you have to do the right hand side rotation. So here the 2 will be there at the top and 3 will be coming to the down and 1 as usual in the left hand side of 2. This is the way the tree will be constructed. So now I have to take the balance factor. 0 minus 0 equal to 0. 0 minus 0 equal to 0 and 1 minus 1 equal to 0. The tree get balanced. So this is the way the left hand side rotations will be takes place. So the next level rotation is right left rotation. So now I would like to explain with the small numbers. So insert 1 3. So these are the numbers I taken to insert. So first you have to take the incoming node is called as 1. So whenever we are going to get the first node is called as the root node. So you have to calculate the balance factor 0 minus 0 equal to 0 because there is no left and there is no right. And now you have to do the insertion of 3. So first you have to compare with 1. So 1 is lesser than the 3. So come to the right hand side. In the 1, you have to form one node is called as empty node and place the value called as 3. And the 3 should be placed at the right hand side of 1. So the tree is placed. So now how to do the balance factor. So 0 minus, there is no left and there is no right, and 1 there is no left hand side, so 0 minus, and the right hand side only 1 is there, so minus 1. So as of now the conditions are true, and now we are going to insert number 2, and now you have to insert number 2. So while we comparing with 1, 2 is greater, so come to the right hand side, and while we comparing with the 3, 2 is lesser, so come to the left hand side, and now you have to check the balance factor. So according to, there is no left, there is no right, so 0 minus 0. According to 3, so only 1 in the left hand side and 0 in the right hand side, so 1. According to 1, so in the left hand side nothing will be there, so 0 minus, and the right hand side we have 2 levels are there at the most, so 2, so minus 2. Conditions are false, so it is exceed than the limit of balance factor. So now we have to do the rotation. So just I will give one tip. When the tree is increasing the right left fashion, just remember this, right left fashion. First you have to do the right side rotation and then you have to do the left hand side rotation. So whenever the tree is increasing in the right as well as the left fashion, you have to take this rotation. First you have to take the right side rotation, then you have to do the left hand side rotation. And now you have to take this same in the formula of this tree. First you have to check that whether the right rotation will be takes place. So in this place we can able to do the right side rotation. So now we can check with this place. So where the rotation will be takes place. The first you have to do the right side rotation. The 3 should be coming to the down position, and after this rotation, so before that you have to check the in-order traversal of the given tree. So the in-order traversal of the given tree is, so first you have to visit the left node, so there is no left, visit the root node, then come to the right hand side, then you have to check with the left hand side node, so 2, and then the root node, and there is no right hand side, you can leave it. So your answer is 1 2 3. So after the rotation also you have to take the in-order traversal. So first you have to visit the left hand side, there is no left, then come to the root node. The root node is 1, so then come to the right hand side. If it is the parent node, come to the left hand side, there is no left, then come to the root, and once you visit the root node, come to the right hand side. So this is your answer. So your rotation is as of now correct, and now you have to check the balance factor. So according to the situation 3, so 0 minus 0 is equal to 0, and now according to 2, there is no left hand side, so 0 minus, and right hand side we have only 1, so minus 1. Conditions are true. And 1, there is no left hand side, so 0 minus, and the right hand side we have 2 levels are there, so 2, so minus 2. So now you have to take the rotation of top level rotations. So this node will be coming to the down position. After this rotation, the 1 will be coming to the down. So 2 will be make it as, so 2 will be make as a root node, and then 1 will be coming to the left hand side, and 3 will be present at the right hand side of 2. So the balance factor is 0 minus 0, 0 minus 0, and 1 minus 1 equal to 0. So now the tree get balanced one, and this is the way the tree will be get balanced. So first I am going to take the value number 1. So first I am going to insert number 1. So first you have to create one node and insert the value number 1 and check that there is no left and there is no right will be there. So 0 minus 0 equal to 0, and the next value is insert number 2. So where the 2 will be placed, the 2 will be placed in the right hand side of 1. Why? Because 2 is greater than the root node. So the root node is called as a 1, and the 2 will be coming to the right hand side, and then you have to place the value of number 2. And now you have to check the balance factor. So for 2, 0 minus 0 equal to 0, and 1, there is no left hand side, so 0 minus, right hand side we have only one level is there, so 1, so 0 minus 1 minus 1. So conditions are true. So now I am going to insert number 3. So what will happen? First you have to check with 1, so 3 is greater, so come to the right hand side. So now we have 2. 2 is lesser than the 3, so come to the right hand side. So create one node and place the value called as 3. So the 3 is placed, and now have to check the balance factor. So here 3, 0 minus 0 equal to 0, and 2, there is no left, so 0 minus, right hand side only 1 is there, so minus 1. in the 1 there is no left, so the right hand side we have 2 levels are there, so 2, so the answer is -2. The imbalance factor is occurred. Already I said when the tree is increasing in the right hand side fashion, do the left hand side rotation at the top level. So here after the rotation 2 will be become the root and 1 will be the left hand side and 3 will be in the right hand side. So now how to check the balance factor? 0 minus 0, 0 minus 0, and here 1 minus 1, so 0. Conditions are true, so it is satisfied the balance factor 0 minus 1 1. So as of now 3 is inserted. So now I am going to insert number 4. So first you have to compare with the root node 2. So 4 is larger, come to the right. So in this 3 is compared with the 4, so 4 is greater, so come to the right hand side. So now I have to check the balance factor. So for 4, 0 minus 0 is equal to 0. For 3, 0 minus 1 is equal to minus 1, and 1, 0 minus 0 is equal to 0. For 2, left hand side only one level is there, and right hand side we have 2 levels are there, so 1 minus 2 is equal to minus 1. So that means the right hand side is one level higher than the left hand side. As of now the tree is balanced 1. And now I am going to insert number 5. So first 5 will be compared with the root value, so the root value called as a 2. So 5 is larger, so come to the right hand side. And compared with the 3, 5 is larger, so come to the right hand side. And 4 is compared with the 5, 5 is larger, so come to the right hand side. Come to the right hand side and place the new node, and the new node value called as a 5. And now we have to calculate the balance factor. So for 5, 0 minus 0, so the answer is 0. And number 4, 0 minus 1, so answer is minus 1. And the 3, 0 minus, because there is no left hand side, so 0 minus, and the right hand side we have 2 branches or 2 levels are there, so 2, the answer is minus 2. And this 1, 0 minus 0 is equal to 0. And number 2, there is only 1 is there in the left hand side, so 1 minus, and the right hand side we have 1, 2, 3, so 3's are there, so 3. So 1 minus 3 equal to minus 2. So 1 minus 3 equal to minus 2. So the imbalanced factor is occurred in this place as well as in this place. So now you have to visit that from bottom to top where the problem is arised. And before that already I said when the tree is increasing in the right hand side fashion, do the left hand side rotation. So according to the situation you have to visit from bottom to top. So 5 to 4 there is no issues, and 4 to 3 the issues are arised. Now you have to focus on this place, and now you have to do the rotation of the given place. So after the rotation the 3 will be coming to the down position and 4 will be placed at the root node of the given place. So now 2, and the left hand side as usual 1, and the right hand side we have number 4, and the left hand side we have 3, and the right hand side of 4 is called as, and now you have to calculate the balance factor 0 as well as 0, here 0, here 0, as well as here as minus 1. Why? Because only 1 in the left hand side, so 0 minus right hand side we have 2 levels are there, so 2. So in the left hand side, so now how to calculate the balance factor of root node. Now how to calculate the balance factor of root node. So in the left hand side only 1 level is there, so 1 minus, right side we have 2 levels are there, so 2. 1 minus 2 minus 1. Conditions are true. So the 5 is inserted. After the insertion the rotation is take place, the left hand side rotation is take place. And now I am going to insert number 6. So how the 6 will be inserted? So first you have to compare with root node. So the root node value called as 2, so 6 is greater, so come to the right hand side. And now so 4 is lesser than the 6, so come to the right hand side. So 5 is lesser than, so 6 will be placed at the right hand side of 5. So create one node and place the value 6, and you have to make the connection of 5 of right hand side. So the node will be inserted at the right hand side of 5. And now you have to calculate the balance factor. So here, so for 6, so 0 minus 0 equal to 0. And 5, there is no left, so 0 minus 1. So the answer is minus 1. And 0 minus 0, the answer is 0. And here 0 minus 0, answer is 0. And for 4 there is only 1 in the left, so only 1 in the left, so 1 minus 2 in the right, so 2. So answer is minus 1. It is one level higher than the left. And for 2, so here you have to take the left hand side value called as 1, so 1 minus, and the right hand side we have 1 level, 2 level, 3 level, so the answer is 3. 1 minus 3 equal to minus 2. And now the imbalance factor is occurred. So now you have to take the which rotation we need to takes place. So how to find the rotation first? Already I said when the tree is increasing in this order, so you have to do the left hand side rotation. So but we have the node is called as a 3. How will you do the execution of this type of rotation? And now you have to take the value, and now you have to do the rotation. Already I said when the tree is increasing in this fashion, do the left hand side rotation. But just forget about this 3. Okay, so now you have to take the in order traversal because we are going to do the rotation. So first you have to take the in order traversal. So come to the left hand side, 1 is your first answer. Then come to the root, the 2 is your next answer. Come to the right, then you have to use the left root right. So 3 is your next answer. Then 4 is your next answer. Then the right hand side node may have any branches. Come to the left, there is no left. Then come to the root 5 and the right side value called as 6. So this is the in order traversal of the present tree. And now do the rotation. So already I said when the tree is increasing in this order, do the left hand side rotation. So first you have to take the root as it is because the problem is arised from top to bottom. Okay, and now you have to do the rotation. So now you have to do the rotation. So the problem is arised in this place because the 2 minus 2 will be here. So the problem is arised in this place. So in this place the problem is arised. So now you have to do the rotation of left rotation at the top. So now 4 become the root node, 4 become the root node, the left hand side value called as a 2 and the left hand side value called as 1. 2's left hand side is 1. So the left hand side branch is over. And the 4 right hand side we already have the value called as a 5. And 5 right hand side already we have the value called as 6. And now the balance 3 should be inserted as it is. So while we comparing to 4, 3 is lesser. So come to the right hand side. Sorry, come to the left. So while we comparing with the root node, the 3 is lesser. So come to the left hand side. Comparing with the 4, the 3 will be lesser. So come to the left hand side. And comparing with the 2, 3 is greater, so come to the right hand side. The right hand side create one node and place your value. And now you have to check the balance factor. For this is 0, this is 0 and this is 0. And here 1 minus 1 is equal to 0 and 5, 0 minus 1 equal to minus 1. For 4, left hand side we have 2 levels are there at most, so 2 minus right hand side we have 2 levels are there, 2. The answer is 0. So the tree got balanced. And first you have to check that whether the in order traversal is correct or not. So first you have to take the in order traversal. The left hand side most node is called as a 1. So the answer is 1, comma, the root node is 2 and the right hand side node is 3. Once you visit this left hand side branch, then visit the root node is called as a 4. Then come to the right hand side. Right hand side, if any node having the branch, go to the left. There is no left. Then go to the root and go to the right. So your in order traversal is matched with the after the rotation also. Your rotation is correct. Now I am going to insert number 7 in the existing tree. So first you have to compare with the root node. 7 is greater, so come to the right hand side. And compare to 5, 7 is greater, come to the right hand side. And compare to 6, 7 is greater, so place your node at the right hand side of 6. So now you have to check the balance factor. For 7, 0 minus 0 as 0. For 6, 0 minus 1 equal to minus 1. For 3, 0 minus 3, 0 equal to 0. For 1, 0 minus 0 equal to 0. For 2, 1 minus 1 equal to 0. For 5, there is no left, so 0. So 0 minus, and the right hand side we have 2 levels are there for 5. So here the answer is 2. So the answer is minus 2. The conditions are imbalanced. And come for 4, there is 2 levels are there in the left hand side. So 2 minus, and the right hand side we have 1, 2, 3. So 3 levels are there. So condition is minus 1. The tree is balanced. For but this place, the tree is imbalanced one. And now how to do the rotation. Already I said when the tree is increasing in this fashion, do the left hand side rotation. So now we have to do the rotation. Already I said when the tree is increasing the right hand side fashion, you have to find the mistaken place and you have to do the rotation. So now the 5 will be coming to the left hand side position and 6 will be going to the root node of the place. So after the rotation, 6 will be placed in the root and 7 as it is placed in the right hand side of 6, and the left hand side you have to form the 5. So now the 5 is placed. Now you have to check the balance factor for 7 0 5 0 3 for 0 1 for 0 2 for 1 minus 1 equal to 0 and 6 1 minus 1 equal to 0. For 4 there's a 2 level in the left hand side, so 2 minus, and the 2 level in the right hand side also, to 0. So the tree got balanced. So if you want to take the in order traversal, you can take it. For the left hand side, 1, the root value is called as a 2, the right side value called as a 3, then root value called as a 4. Then come to the right hand side. If it is a parent node, come to the left, there is no left, then root. Then come to the right. If it is a parent, come to the left, there is no left, and 6. And the right hand side value called as 7. So now after the rotation, you have to take the leftmost node is called as a 1, then go to the parent node is called as a 2, then go to the right hand side is called as a 3, then go to the parent node is called as a 4, then come to the right hand side. If it is a parent, go to left, then go to the root, then go to the right. So the answer is correct. So your rotation is correct. So now I am going to insert number 8. So first you have to compare with the root value. So the root value is 4. So 4 is lesser than the 8. Come to the right hand side. So now 6. So 8 is greater than 8. So come to the right. Then 7. 7 is compared to the 8. 8 is greater. So you have to find one node. So you have to place this value in the right hand side of 7. So 8 will be placed. And now you have to take the balance factor for every node. So 8 for 8, 0 minus 0, answer as 0. And 5, 0 minus 0, answer as 0. For 3, 0, 1, 0. And for 2, 1 minus 1 equal to 0. For 7, there is no left, so 0 minus 1 equal to minus 1. For 6, only 1 in the left and 2 level in the right, so 2. So answer is minus 1. For 4, there is a 2 level in the left, so 2 minus, and the right hand side 1 2 3, so 3. The answer is minus 1. So the tree got balanced, and this is the way the AVL tree can be performed. So thank you for watching this AVL tree. In future I would like to explain with another example of AVL tree if you want. So kindly watch my channel for all data structure concepts. Thank you for watching my channel. Thank you.